Why, hello, this is section 8.3. We are going to be working with, that's right, exponents. Probably your favorite thing by now. But don't worry, it'll only be a little painful. Let's start out with an example problem. What is the easiest way to solve this problem without a calculator? X to the fifth over x to the fifth. It'd be a good time right now to think about your quotient rule. What did we do? What did we do? Oh yeah, we did this thing where we canceled. And I'm going to cancel that one. X over x is 1. Cancel. And cancel. And cancel. And cancel. Why did I choose x to the fifth? So much canceling going on. Hint, hint, hint. X over x is 1. Which means that this is reduced to 1 times 1 times 1 times 1 times 1. Which means x to the fifth, or x to the fifth, is 1. Yay! Wait! What about the quotient rule? Well, let's check it out. The quotient rule said that if I have two bases that are the same and divided, that I could subtract the top exponent from the bottom exponent, which is like that. So, what exponent do I get then? 5 times 5 is 0? Huh. So, what's the answer? Is it x to the 0? Or is it 1? What are you thinking? They're the same. So crazy. I know. Let your brain sit on that one. Force it to go in. Okay, I think mine's in there. All right, so let's try out your skills here. Y to the 8th over y to the 8th is... Oh, hopefully you got it. Y to 0, which equals 1. Try the next one. X to the 3rd times y over y times x to the 3rd. Time's up. There it is. X to the 0 times x to the 0 equals 1. Perfect. All right. What about this big one down here? X to the 3rd times z to the 5th over x to the 1st times z to the 5th. I'll give you a moment here. Okay, time's up. There it is. X squared times z to the 0 equals x squared. That's right. So, what about negative exponents? We've got them complete. We've got the other ones completely canceled out, right? Now we've got these little weird negative thingies. How do they work? This is even more crazy. I'm sorry. So, for the negative exponents, we're going to try to find some patterns in the data. Right? 8 divided by 2 is 4. Doing it one more time here, we get 4 divided by 2 is 2. Right? Do it one more time. 2 divided by 2 is 1. 1 divided by 2 is 1/2. And 1/2 divided by 2 is, it's fractions. Okay, let's do some work. 1/2 divided by 2 is equal to 1/2 times the reciprocal. So 2 is in 1/2. So then I multiply straight across and I get 1 and I get 4 on the bottom. Right? So 1/4. Awesome. All right, so let's look at the left side now. What kind of pattern are we seeing there? We say that 2 to the 3rd, 2 to the 2nd, we're just minusing 1 from the exponent. For the next line, we get 2 squared to the 2 to the 1st power, minusing 1 from the exponent. And we can do that. 2 to the 1st minus 1 is 2 to the 0. 2 to the 0 minus 1 is, negative territory. 2 to the negative 1. 2 to the negative 1 minus 1 is 2 to the negative 2. So, what kind of patterns are we seeing here? Well, first thing I'm noticing, I like to go with my whole numbers, right? I'm noticing that my 4 up there is as a big number, whereas it's down there on the bottom of a fraction. So I could say, well, that's the reciprocal. Okay. And I'm seeing over here, if I go straight across, that 2 squared and 2 to the negative 2. Well, the only difference between those is this negative sign in front of the exponent. So taking what we know from here, the fact that 2 squared equals 4, and 2 to the negative 2 equals 1/4, we can figure out our exponents rule. A to the negative n equals 1/n. When a goes from the numerator, it's on the numerator on the left side. It's got that imaginary 1 underneath it. When we flip it, the exponent changes signs. Let me say that one more time. A to the n's in the numerator. When I put him down in the denominator, I change the sign on the exponent. So let's try out your skills. 4 raised to the negative 3. How can I make that a positive exponent? How can I rewrite that? I'll give yourself a moment here. Okay, 1/4 to the 3rd power. Right? 4 to the negative 3 is in the numerator, so I'm going to flip it down to the denominator and change the sign in front of my exponent. Give x to the 3rd over x to the 8th a try. Okay, 1/x to the 5th. Using that quotient rule, I could see that 3 minus 8 gives me this negative 5. X to the negative 5. X to the negative 5 is in the numerator. I put him down in the denominator, and looky look. We've got that positive exponent up there, which we like. Give the last one a try. All right. Hopefully we get something very, very close to this. All right. So I see that z to the 3rd over z to the 7th. I use my quotient rule, and I would find that z would equal z to the negative 4. Right? I don't want a negative exponent. So I'm like, okay, no more numerator for you. You go down in the bottom. Right? It's like a little punishment because he's negative. He's being very pessimistic. Right? So we get z to the 4th down there at the bottom. Y to the 5th is up on top over y to the 2nd. Right, so he's up on the top. He's being a little more positive. He gets to stay in the numerator. We can still use our quotient rule to figure out that y to the 5th times or over y to the 2nd power is y to the 5 minus 2, which is y cubed. All right, for just a little bit of fun, you can head back into the Moodle segment there. We're going to be singing, or we're not going to be singing. I hope you can sing along to this because it's totally lots of fun. It's Eye of the Tiger, but it's Eye of the negative exponents. It's really awesome. Give it a try.